Hello everyone, welcome to ML with AP. The topic for today is Numpy. We are going to take a look at top 30 commands in 30 minutes and will completely master Numpy. So let's get started. But before that, what is Numpy? I'm sure many of you are already aware of this, but Numpy is short for numerical Python. It's an open source Python library, super useful in case of data science, machine learning and deep learning work. Since it is so useful and so flexible and so fast, it is also being used as a base library for pandas, scipy, matplotlib and scikit-learn and many more, right? Now numpy is always considered very fast, right, especially for numerical data. Now why it is fast? It is faster than python list, it is faster than pandas data frame. Why? I'll try to give you a hint right now, and later down the line probably we'll discuss that in more detail. The hint is vectorization and broadcasting. These are the two capabilities which NumPy has, which makes it super fast. Okay, it completely done away with looping, so there is no looping or need for looping in NumPy. Now, another or secondary reason why NumPy is so fast or faster than the Python list or pandas data frame lies in the fact that NumPy is also written in C, similar to what Python interpreter C Python was written in C. NumPy is also written in C, and it uses the C compile libraries, which makes it faster. I have made a separate video on why C or a static type language is faster than a dynamic type language. If you have not watched that, please go ahead and watch it. Moving on, the basic data structure or the data type for NumPy is ND array, short for n-dimensional array. It's a data construct for array, and it can have one dimensional, two dimensional, or more than two dimensional also. In that case, we call it n-dimensional. One of the important rule for NumPy is that the NumPy should carry only homogeneous data types within it. So the array can only carry homogeneous data types. If you are creating an array out of a integer, only integer values can be present over there. If you are creating with float, only float can be present, or any data type for that matter. It has methods for all mathematical operations, very advanced mathematical operations like Fourier transform, and everything is present in NumPy. Tensors, which is used in especially with the TensorFlow framework and used in deep learning, are nothing but n-dimensional arrays. So vectors or the 1D array or 1D tensors are vectors. They are nothing but a row or a column vector. Matrices are usually two-dimensional array. In case of NumPy, in case of tensor, we call it 2D tensor. More than 2 or 3 or 3 plus dimensional array, we call it tensor in TensorFlow framework. In case of NumPy, we call it n-dimensional array. That's the difference. Now the first thing first, you have to install the NumPy. The way to install is pip install NumPy. I have already done that, but you can run it like this and install NumPy. Now the second thing is that we have to import our libraries as usual. Before that, we have to, after importing the libraries, one of the things is that, hey, how do we construct NumPy arrays? It's very simple. Using Python list, we can create, there are a couple of other methods also to create NumPy arrays, but the most popular one being through the list. So let's say we have a list over here. If you see in the square bracket, 1 4 2 5 3, this is my list. I passed it through the array constructor over here for NumPy, and it gave me an NumPy array 1 4 2 5 3. Now, as I was seeing that NumPy arrays are homogeneous, right? So what will happen if I pass a float and the rest of the value is integer? Watch it out. Okay, so if I passed, what it will do, it will upcast it. Upcast means it will cast it to the next higher level data type. In this particular case, these three were integers, this was float. So to make it homogeneous, what NumPy did, it made every element of the array as a float, right? You can also get the information from what data type its members of the array has by x.data type, x.d type, and it will say float 64. Okay, you can also explicitly also set the data type in case you are passing the integer but you want it to be set as float. So there is another argument which you can pass with the array constructor which will set it to float. So if I want to set it to float 32, I can very well set that. Now, as I was saying that it's not just a column or row vector, but you can create multi-dimensional array, ND array also. Let's try to create a two-dimensional array. In this particular case, we have to pass a list of list. If you see over here, I'm passing a list of list over here, right? And if I run this, one of the attribute of Numpy arrays are shape, so it will give you the shape information, and it calls it that X is a 3x3 n-dimensional array, or 3x3 two-dimensional array, right? Array with full zeros. You can sometimes there will be a need, especially for the initialization of your models or setting the weights, that you have to create a Numpy array of a fixed dimensions or a fixed shape with all zeros in place, right? It is very simple, straightforward to create. You call the method np.zeros. You want 10 elements over there, and the data type should be integer, and it should be all zeros. Once we run it, we'll get an array with 10 elements over here, all zeros. Similarly, the counterpart to get 1 is all ones also, np.ones, 3x3. We can get a multi-dimensional or two-dimensional array also with the data type integer 1 1 1 1 1. Now you can also populate it with a random integer. So the np random.rand function will auto-generates any random number between 0 and 1. And what I'm passing the 4 5, that I'll give me a 4 row by 5 column two-dimensional array for Numpy, okay, and it will give me, so it will generate, I am storing that in z variable over here. So this z array, you can see there are 4 rows and 5 columns it has generated, and it has populated that with a value randomly generated between 0 and 1. Okay, so these are the ways there are a couple of more ways also, but these are essentially the ways in which you can create a Numpy array. How do you get the information about array? If the array is given to you, what shape, what size? So let's see that. So this is my Z array over here. If I do a ndim over there, it will give me the dimension. So this is a two-dimensional. So hence the answer is 2. N-dimensional, that means two-dimensional. So it is coming as two-dimensional. I'm just fetching the dimensions of this particular array. Is the size? The size is 20. How many elements are there? 5 cross 4, 20. What is the shape? We have already seen this before. It is 4 cross 5. The first is the row, the second is the column. 4 cross 5. And the size will always be a multiple of these, 4 cross 5, 20. And this is two-dimensional. If this would have been a three-dimensional array, let me put it over there. And if it would have been a three-dimensional array, so you see this, it generates a three-dimensional array. Now, if I do a ndim over there, it will give me 3 because it's a three-dimensional array. The size will also accordingly change. Into 3, it will be 60. The shape will be 4, 5, 3 now, 4, 5, 3. Okay. For the purpose of the demonstration, let me switch it back to a two-dimensional array. So I have switched it to 4, 5. Let me run it, and I got my values in a nice two-dimensional 4 cross 5 matrix. Again, I will run my dimension. It's two-dimensional, size 20, shape 4 cross 5. Let's see how do we want to access the elements of a Numpy array. Now the way to access is, again, it's very similar to Python list. It's a zero-based indexing, row and column. So if I mention Z0, that means I'm asking for all the row from the first row. So I'm asking from the first row. So if you see my first row over here and over here, this is the row I'm fetching, okay? Anything before the comma is the first dimension. In this particular case, in a two-dimensional, it will be row. Second will be the column, the second dimension. So now I'm asking it for, give me the first row and first element, first row and then the second column, first row and second column element. So the first row and second column, this is the second column, this is the first column, this is the second column. So 0.05, let me run it, 0.05412. So it has fetched this particular value from there. Okay, clear? So just to repeat, before the comma, this is the first dimension, which is row, this is the second dimension, and this is how you do the indexing and fetch the data. The slicing also works very similar based on the zero-based row and column indexing. if you have seen my, it's very similar to how the list works or the pandas data frame works. Okay. Before the comma, if I am putting a semicolon or a colon, I'm trying to retrieve all the values. By this colon, I am stating that give me all the values, and here I'm asking for the first column over there. Okay. So what I'm trying to get all the rows, but only first column. So if you see over here, I'm fetching this particular one, the second column, right? 0.05 to 0.043. Let me just, where are they? Here. Yeah. So I'm getting, and one thing to note, friends, over here is that in Numpy one-dimensional array, there is no difference between a column or a row vector, right? That's why it is being represented in a horizontal way rather than a vertical way, if you're expecting that. Okay, now what I am trying to get here, I'm trying to get, let's first read this thing. This thing says that start from the very beginning, go all the way till third row and fetch all the columns. Okay, so all the way till third. So this is the 0th, first, second, don't include third. Like the end is not included, right? Even in the case of list, this is the similar thing. The end is not included over here. So 0th, first, second row and all the columns. This is how I have sliced it. Now, if you have to slice every other row, that means I'm not putting a comma, so I'm only asking for the row or the first dimension. So start from the very beginning, go till the very end. And what is the step size? The third thing after colon is the step size. So step size is that skip one. If I have mentioned 2, that means skip every other row. So it will fetch the first row, the 0th, and then it will skip the first and then the second one, right? Or 0 and 2 it will give you. So first and third, it will give you these two over here. Okay, now let me run that. Okay, yeah. Now just to ensure that we are getting the right result, this is the Z. It is fetching me the first and the third, so it's skipping one skip, right? Now similar to what we are doing for data frames or list, if you have, it's the indexing is 0 based and the steps are in the reverse order also. If you mention -1, what you're saying is that from the very end till the very beginning and count it in the reverse way. The step size is -1, that reverse way. So what it will do, since I have not mentioned a comma, it is asking for the row. So the rows will be reversed. The last row will be the top row. The second last will be the second row. And if you can see over here, let me run this so that it becomes more clear. Okay, so my last row was 0.03. It became the first one. The second one was 0.29. It became the second one. Over here, if you see 0.08, and the last one was 0.18. 0.18 went over there. Similarly, for the column reversal, you have to fetch all the rows, then a comma, and then with this particular syntax, what you are showing is you are reversing the column. So the last column became the first column and vice versa. Numpy accesses. Now this is very important. As I was saying that the first access is your row. This is the first access. And in case of 1D array, it doesn't matter whether it's a column or a row vector, it doesn't matter. Whatever is because it's a single dimensional array, that dimension itself becomes axis 0. Okay. In a two-dimensional array, the axis 0 is always the row ones, right? This is axis 0, and this is the where you are counting the column, it becomes the axis 1. In case of three-dimensional array, if it is 4, 3, 2, the axis 0 is again your rows axis. The second axis, axis 1, will be your column axis, which is this one, and the third axis, which is the depth side, right? So in case of 4 cross 3 cross 2, this is the 0, this is the 0 axis, this is the 1 axis, this is the 2 axis. Now let's see that where it will be useful. So if I have to get the Z shape, it is 455. Okay, so there one of the function or the methods which is available for Numpy is the reshape. Sometimes you may have to reshape a particular array, a two-dimensional array, into one-dimensional and vice versa. And the reason for reshaping is mostly flattening. Sometimes it is used for deep learning convolution, neural nets and all, right? And there are other use cases also. So if you have to do, you just have to use the reshape function. And I'm reshaping Z, which is 4 cross 5, which was 20 element. I'm reshaping into 20 into 1 again. So the element should match. That's the only condition. If I, let's say, if I put by mistake 20 cross 2, it should error out, right? It will give you the value error. It will clearly say that cannot reshape the array of size 20 into shape, because 20 into 2 will be 40. So the size should have been 40. Otherwise, it will not work. Concatenate. You can concatenate two arrays also. Let's define an array, a two-dimensional array like this. So this is my array. If I have to concatenate x with x, then if you see 1 2 3 was there, 4 5 6, then it is vertically stacked. Vertically stacked means the axis 0, by default it will take the concatenation with respect to axis 0. What was my axis 0? My axis 0 is this particular thing, right? So it will concatenate based on this, and then that's why it is putting one on top of the other, right? You can also specify another argument or parameter over here, axis 1. If you do axis 1, then it will be columnized, so it will be extended horizontally in the column fashion. Okay, simple. Now here is the thing, right? Why Numpy is so powerful, so fast? This is the reason. The power of vectorization. There is no loop, and there is another functionality which is called universal functions, which Numpy has. Let's see, let's try to understand this with an example. So I have defined a particular Numpy array, and with a range function, so it is 0 1 2 3 will be my Numpy array. And if I want to multiply that array with 2, you are actually multiplying a vector with a scalar, which should not be allowed, but in case of Numpy it is allowed, and this is the crux of the matter, that it's so powerful, and we'll just see it in a minute. So x multiplied by 2, we can do that. That operation is perfectly valid in this case, and see what the result will be. The result of this thing is that 2 is individually multiplied with each of the elements of array x. So the array x was 0 1 2 3. Now 2 gets multiplied to each of these elements individually over here, right? And the result which I see as of x multiplication 2 is 0, 2 into 1 2, 2 into 2 4, 2 into 3 6, right? So this is the beauty and the power of Numpy, and where it is used we'll just see. Suppose you had to do the same operation. If this functionality was not there, what you would have done? You would have to write a loop, right? You have to write a loop, read each of these elements one by one, multiply by 2, and store it. This is what I'm doing. So I'm initializing I is equal to 0. I'm writing a small for loop for I in x. In x is an iterable, so 0 1 2 3 it will iterate. And then what I'm doing is I'm fetching the individual element, multiplying it by 2, storing it in the same variable, and then I'm printing. This will also give me the same result, 0 2 4 6. Now friends, you tell me whether this is more efficient or this thing is more efficient. Obviously this thing is more efficient. With one stroke or one line of code, you are eliminating the whole for loop. The for loop is a costly operation, and that makes Numpy so fast. Okay, not just that, you can do operations, complex operations like this also. So I'm again multiplying it by a scalar, I'm adding with a 1, I'm again doing the exponentiation, anything, or the power of 2, any operation, mathematical operation you can do on the vectors or n-dimensional array, and that is perfectly valid. And this makes it again so powerful, right? So if I do this again over here, not just this, let me show you that some of the, like natural log, if you have to take, you can take the natural log of x. X is an array over here, and what will happen? The natural log will be implemented on each of these elements separately, and then the result will be stored. Okay, let's see. Now the universal functions, one of the powerful universal function is reduce. Let's see what reduce that. It minimizes it does what it tells you, it reduces it. So If I have to, again, I defined a particular array as x is 1, 2, 3, 4, 5. If I do a numpy.add.reduce, that means I'm asking the array to be added and then reduced to a single scalar quantity. So what it will do, it will add all this, the sum of these elements, okay, and then by reducing, I'm asking it to reduce and give me a single scalar value. Okay, I can do multiply reduce also. That means each of these elements will get multiplied with each other and then finally reduce into one scalar quantity. So 1 into 2 into 3 into 4 into 5 comes out as 120. I can also do a cumulative addition. So when I do accumulate, that means I'm passing, do an add and then accumulate. Accumulate means like do it cumulatively. So 1 plus 2, 1 is 1, 1 plus 2, 3, and then after 3, next number multiply, add, because the add operation is there, 6, then 6 plus 4, 10, and then 10 plus 5, 15. So this is like a, it can be used in making a histogram or a frequency chart where we need the cumulative frequency also. Matrix multiplication. Now the crux of the deep learning or most of the machine learning is also matrix multiplications, right? Most of the data which are passed to our models, especially in the case of deep learning, has to be numerical, right? And when we pass, even the categorical data needs to be converted into numerical data. And when we pass, then one of the things which deep learning does, it's at the very fundamental level, it is matrix multiplication, and right. So matrix multiplication is by default implemented in Numpy, and the way to do that is, let's define a particular, we are generating a particular array and we are reshaping into 5 cross 1. The second array y1 we are reshaping into 1 cross 5. So let's first see, before multiplying, what is the x1. So x1 is my 5 cross 1, 5 row 1 column matrix, 1 2 3 4 5. y1 is the shape, it's 1 row 5 column. Now matrix multiplication, if you remember from your algebra classes, is that the way matrix multiplication works is that if it is 5 cross 1 and 1 cross 5, one of the primary condition is that the column of the, or the second element of the column of the first whom it is multiplied, that matrix, and the row of the matrix which is getting multiplied to should match. So 1 1 should match. And what will be the resulting size of that matrix? The resulting size should be 5 into 5. Okay, so this is the basic linear algebra. If you would have seen that, this is how the matrix multiplication works. Now in this particular case also matrix multiplication works the similar way. So what it will be, the normal thing, the first row will be multiplied with first column, 1 into 6 will be 6. The second row multiplied with the first column, 6 into 2, 12, and similarly we will get a 5 cross 5 matrix over here. So the matrix multiplication also, in case we do not have this matmul function and this vectorization concepts, then to achieve a matrix multiplication you would have to actually run loops, right? Multiple loops to create this, right? Now there is something called aggregation also. So it will give you lot of mathematical functions, and the way it works, again, let's see it with an example and it will become much more clear. So we defined again a random array, randomly initialized array with a size of 3 cross 4, 3 rows and 4 columns. Let's print it. If I have to do a m.sum, we can get an aggregate function over here, right? It sums all the elements and it will just give you the sum of it. If you specify an axis, the axis 1 is we know that the axis 1 is this columns, right? If you specify axis 1, then what it will do, in this particular axis, it is going to do the sum. So it will, this is my first, right? This is the axis, this is the direction of the axis 1. So it will do a row wise addition. So my first row is added over here, second row will be added over here, third row will be added over here. If I do a min, similar thing. If I do a max, there are a lot of other operations also, very statistical operations like standard deviation, variance, min, max, argmin. Argmin is the minimum value or the maximum value or the median. You can percentile. You can figure out all of these aggregate functions using just one command, right? On a n-dimensional array, or n-dimensional matrices, right? Which is so powerful. Now, one of the key things which we have not talked about is broadcasting, and in some way we have seen that how it works, right? So let's define two matrices over here, or two vectors over here, a and b. A is 0 1 5, the b is 5 5 5. If I have to do a plus 5, a plus b, now we know that it will work, right? Because these dimensions are same. So what the broadcasting will do, it will element wise do addition. So 0 plus 5, 1 plus 5 and 2 plus 5, and the resultant of a plus b will be 5 6 7. But here is the cool part. If you do a plus 5 also, it will work. Now with the ufunc, we know that the operation, a mathematical operation between a vector and a scalar is also possible, right, in Numpy. So what exactly is happening over here? A 0 1 2. What broadcasting does over here is that it will elongate, or it will expand my 5 into a 5 5 5 of the same dimension as A. It will construct an array, a temporary array of the same dimension as A to fit it with. Okay, so this operation a plus 5 and a plus b are exactly same. This 5 will also get expanded into a similar array of 5 5 5, and then the addition operation will take place. This particular expansion or elongation is known as broadcasting. Okay, clear? Now let's see another example. Let's say we are creating a 3 cross 3 with ones. Okay, no problem, we create it. Now we are adding m plus a over here. Now what was my a over here? My a was, m is a 3 cross 3 dimensional array. My a was a 1 cross 3 dimensional array. Now with the broadcasting rule, this also get elongated or expanded into the same dimension as m. Okay, so ultimately when we are doing m plus a, m is this, a will become 0 1 2 0 1 2 0 1 2. It will also become a 3 cross 3 dimensional array, and then it gets added over here. This is how broadcasting works. Okay, now one of the last topic is that comparisons and mask and boolean logic, right? Similar to pandas data frame, we can create logic, or list, we can create logic also over here. Let's see how we can do that with an example. So we are defining an numpy array over here. Let's say if we have to mask, this is the masking concept. If x is less than 3, let's say, so it will find all the elements over here where this condition is true, and it will mark it true. So 1 is less than 3, it marks it as true. 2 is less than 3, it marks it as true. True. 3 is not less than 3, 3 is equal to, so that statement becomes false and false and false. So it creates a masked array for this particular condition. Let's say how it will be useful. Suppose we pass this mask condition inside a square parenthesis. It will return me only the true values. What were the true values? 1 and 2. It is returning me an array of 1 and 2. This is how the masking and the boolean logic works. Now suppose somebody is trying to find that are there any values greater than 3? What you can do over here is x greater than 3, you can pass it, and with a special function or method any, np.any x.x greater than 3. What it will do, it will try to fetch is there any value, and it will give you a boolean answer, true or false. The other counterpart of that is all. Are all the values greater than x is equal, it's greater than 2? No, that's why the boolean result is false. Is any value greater than 3? Any value? Yes, we have values which are greater than 3, which are 4 and 5. So this boolean return is true. So this is how and with all these ufuncs and the boolean logic and comparison and maskings and broadcasting, people have created, or you can create a very elaborate logic which is faster without using the explicit a while or a for loop, right, which is costly. Now another case over here is sorting. Let's say if you have to sort a particular list, it will take, if you are not using the default list sort method for list, it will take some time with the for loop. Over here also we have the default method which is present in Numpy for sorting, and it works like this. It is self-explanatory. If you have to do a sort, is sorting the elements. If you do an arg sort, that means you are sorting the index itself. So let's say when I sorted the index, that means it's a zero-based indexing. Remember, this is the zeroth element, this is the first element. So the first element is the lowest, my zeroth element is the second. So it has sorted the index, which was the numerical index, zero-based indexing. It has sorted the index. So sort sorts the element, arg sort sorts the indexes. So you can do sorting and access wise also. Let's create a 4 cross 6 dimensional, two-dimensional array over here. And if you pass the axis, it will start going and sorting it based on the axes, right? So that is also very much possible. Okay. So if you see that it is sorted on the axis one wise, right? If you see over here, yeah. Now one thing to note over here is that these when these are getting sorted, all these rows are independent. So if you have a fixed column with some attribute or something, this will all messed up, right? So be careful about that as well. These all rows are treated independently as like independent, and then it gets sorted if you provide an access. Okay. With that being said, I think we have come to an end of this 0 to hero 30 minutes NumPy. If you like this, consider liking it, subscribing it, and sharing it. It will mean a lot to me. Thank you.